What is the first step in solving a word problem? Same first step always. It's not a tricky first step. It's a pretty obvious first step. Ava?
Write an answer equation.
Before that. Maverick?
Answer sentence.
Before that.
You read it.
You gotta read it. We can't figure out what our unit is or what we're counting for our answer sentence until we read the problem. Let's look at this problem. It says there are 25 desks in a classroom. The teacher puts them in groups of 5. How many groups of desks are in the classroom? We've read it. Now we need an answer sentence. That's step 2, just like Ava and Maverick told us.
Not my step.
Brogan, no thank you. What are we counting? I just see lots of hands. Samaya, what are we counting? I'm counting a little bit more than desks. Look at that last question. The last sentence in the question. Not just groups. Nope, not that. Texas? It is groups of desks.
That means
It is not just desks. It is not just groups. But groups of desks is what we are counting. Let's go ahead and write our answer sentence. No, there's not blank desks. There are blank what?
Groups of desks.
Groups of desks. That's different than desks. I know how many desks there are. 25. I already know that. Bye. Groups of
What's the title?
desks. No title. There are blank groups of desks. Counting groups of desks. We've done step number 1, we read the problem. We've done step number 2, we've read the problem and figured out what we're counting. What is step number 3? This is a really good time for you to practice raising your hand. Archer.
Redraw the problem.
Not redraw.
Reread the problem and draw what's happening.
Reread the problem and draw what's happening. Let's start with that first sentence. It says there are 25 desks in the classroom. Just draw that. I'm going to put them all in one big bar. Kind of like if they were in a pile. Obviously, I know that desks aren't usually in a pile. That doesn't make a whole lot of sense. But I'm just going to put them all smushed together in one big bar. One big box. So far, so good?
Yes.
All right, next problem. Or sorry, next sentence. The teacher puts them in groups of 5. Is she getting more desks?
No.
No. Is she getting less desks?
No.
No, I'm not getting more desks. I'm not getting less desks. The number of desks is staying the same. They're just going to look a little different. Does that make sense?
Yes.
All right, so I'm going to make a bar that's exactly the same size. Because I know she's still going to have 25 desks. She's just made them look a little different. So far, so good? All right. How are these desks going to look? It tells us that in the problem. Jordan, what are they going to look like?
They're gonna be in groups of 5.
They're going to be in groups of 5. All right, well, let me make one group. Here's my one group of 5. I want you to imagine a pile of desks, and you just pulled 5 out to make one group. Are there still more?
Yeah.
Yeah, there's still quite a bit more. So let's try another group of 5. How many how many desks have I pulled out of my pile so far? You could be doing the same thing. How many desks have I pulled out of my pile? Avery?
10.
Where did you get that number? Because I don't see 10 on my board.
I counted by 5s because 5, 10.
Avery is counting these 2 5s. We've used 10 desks so far. That means I still have some desks. Let's make another group of 5. Cole, how many desks have I used now? 15. Let's do another group of 5. Alright, how many have I used now? 20. I bet you can figure out. Do we have enough to make one more group?
Yes.
Do I have any extras left over?
Yes.
No.
Yes.
Right?
No.
Let's see.
No.
5, 10, 15, 20, 25, and 25 to start. So did I have any left over?
Nope.
No. I used all 25 and I put them in my groups of 5. Now, is my answer 25?
No.
No, it's not 25 because look at what it wants to know. It doesn't want to know how many desks. It wants to know how many groups of desks. The groups are this piece right here. How many groups do I have? Raise your hand to tell me. Paxton? I had 5 groups. It just so happened that 5 went in each group, but the number of groups I have is 5. So far, so good? Awesome. Fill in our answer sentence. Step 2, answer sentence. Do step 1 and step 2 and then stop.
Myself?
Right now, yes.
So first is
What am I counting? You should have an answer sentence by now because you had to do step 1, which was read it. Step 2, write an answer sentence. What am I counting in this problem? Cole?
Cards.
I am counting cards. If you had a hard time doing or figuring it out, the question part is very helpful. How many cards should each person get? Each person should get blank cards. You should have something similar to that. As long as you have something similar to that or that, you are good. You don't need to raise your hand and tell me what you got as long as it's similar to that. No, you need a verb. It's not each person blank cards. It's like saying Brogan cards. That doesn't make any sense.
each person got blank cards.
That
That's the
works.
same thing that I did. Each person should get each
Right, we know what we're counting. We know that people are getting cards. Step number 3. Now we need to model it. Connor, read the first sentence to me, please. 4 friends are given a pack of trading cards to share equally. What should I draw? How would I model that? 4 friends are given a pack of trading cards to share equally. What should I draw? Archer, what do you think?
You can draw circles or boxes and give the cards out to each person.
Okay, well, how many circles or boxes am I drawing?
4.
Why?
Because there are 4 friends.
There are 4 friends. Some of you, when you solved a problem similar to this yesterday, you made 4 separate circles for 4 friends. That will work. I'm just going to show you if I smush them all together what that looks like. So I've made my 4 friends smushed together like that. Can you do 4 separate circles? Yes. But can you also do 4 boxes smushed together?
Yes.
Either of those will work. Draw one of them, please. Someone tell me, why do I have 4 boxes drawn? Why do I have 4 boxes drawn? Paxton? Yeah, could I label them? Yeah. Here is friend 1, friend 2, friend 3, friend 4. That works.
No, wait.
That bar matches the first sentence that Connor read. We've got our 4 friends right there chilling, and they want to share a pack of trading cards equally. That tells me they're probably pretty good friends. Each person's going to get the same amount. Let's look at that next sentence. Dorian, can you read that next sentence? Can you see it from there?
Wait.
30. The pack contains 32 cards. When I'm sharing that with my friends, is my total number of cards going to be more than 32?
No.
Are they magically going to get more cards?
No.
Are they magically going to get less cards?
No.
So, if I share them out and then push them back together, how many will I have? I'll still have 32. I'm just now going to share them with my friends. So what I'm going to do is I'm going to draw a bar the exact same size. Why am I drawing a bar the exact same size? Why am I drawing a bar the exact same size? Addison?
So, like, you can put the 32 there.
Nope. That's not why I'm drawing that bar. Maverick, what do you think?
So, you can break on the cards.
Nope. I'm very clear. I want it to be the exact same size. Why? Connor, what do you think?
I think it might be the whole.
Nope. Well, yes, it is the whole, but that's not why I made it the exact same size. Avery, what do you think?
Because it says that that there are 32 cards in all, and they are gonna share it equally. So we're trying to figure out how, like, we're breaking apart that number and putting it into those groups. So it's gonna be worth the same thing.
This bar? Right here. Is equal to this bar. There's the same number of cards. When I deal them out, if I were to push them back together, I would still have 32. So I have made them the exact same size to show that they're equal. Now, does it look exactly the same?
No.
No. One big pile of cards looks different than me dealing it out. But it's still the same value. Does that make sense? Brogan, what's that?
Is these two problems different? These problems the same or different? Because
All right. How many cards do I have? Marley? 32. It tells me that right in the problem. 32. All 4 of my friends put together are going to have 32 cards. They're exactly the same. We skipped this step on accident on our last problem, and I did not mean to do that. But we need to make an equation. What does this match in math language? What kind of equation am I going to be making based on this bar model? Spell it.
32
32.
divided.
Can we use one of those versions of English so I know what divided really means?
Divided into.
So I don't want to use divided because I don't really know what that means. But I can use this language to help me.
Put into.
How many groups?
How many friends I got?
4.
4 groups.
The value is.
Beautiful. Do we know? Did it
No.
say? No.
No,
Mystery.
no.
Beautiful. 32 things. In this case, 32 cards. Put into 4 groups shared with 4 friends. Oops. Equals mystery for each friend. There are other equations I could write. What else could I write? You can write something else. Addison?
Oh, you can do 4
4
groups of
groups of
some blank
mystery number blank
equals 32.
equals 32. On your homework, you could have wrote S or M. That's what that meant. What's that?
But we could have wrote a box.
Or a box. It's fine. Any of that is fine. Or an X. Or a smiley face. 4 groups of mystery number. I have 4 groups of mystery number, and I know that's worth 32. Now we need to solve that. What strategy could I use to solve this? What strategy could I use to solve this? I don't know what you do.
Division.
Okay, but what strategy of division? Like, what are you going to do? Ooh, dealing out strategy. Give me 2 signals if you remember the dealing out strategy.
Same.
All right, I'm going to deal out. 32 is kind of a big number, Cole. So I'm not really feeling dealing out by ones. Can I deal out by a different number?
Yeah, you can go by 2s.
I can go by 2s. All right, I'm going to do that. So 2 for you, 2 for you, 2 for you, 2 for you. How many have I used so far? All right, I don't see your pencil moving. Mm-hmm. 8. 2, 4, 6, 8. I'm going to keep going with my 2s. 10, 12, 14, 16. I'm still pretty far away from 32. So I'm going to keep going. 16, 18, Colton, thank you. 20, 22, 24. I'm still kind of far away. I'm going to keep going 2 still. 26, 28, 30, 32. So, is the answer of what this is trying to figure out each person should get 2 cards?
No.
But I wrote 2 a whole bunch. What is it going to be? Each person should get how many cards? Because I wrote 2 a whole bunch, but you're telling me it's not 2. Mason, what do you think it's going to be? 16. It's not going to be 16. Jackson? How did you figure out it was 8? Can you say that one more time? Added up all the 2s? Every single 2 on the board? All the 2s in just one box. Because I want to know how much each person got. That's only one person. 2, 4, 6, 8. So each person got 8 cards. Sean, are you with us? Rogan, what's up? Yes, that's why I said new page. You have to do a new page. This is your title on your new page. 1 page. We're not flipping over random amounts of pages. That doesn't make sense when we're trying to look back and study later. How to write an equation for a 2-step equation. So far, one operation. Maybe one addition sign, or one subtraction sign, or one multiplication sign, or one division sign. Just one. But we have been learning and working with problems that make us do two things. Maybe add and then multiply. Or maybe subtract and then multiply. Or divide and then add. Hang on, Cole, I see you. So I want to go over this because you will see this next Friday. Hint, hint. You can do it, but I want to make sure you know what it might look like so that we're not stressed when we see it on your test. So far, so good? We got a title, so I'm going to move on to our problem.
So what's the title?
Right there, how to write an equation for a two-step equation. The rules of this equation, this problem still, you're going to have to wait, still are the same. Read it. That's the first thing we got to do, read it. Go ahead and read it. Go ahead and read it.
Rob.
No, in your head, sorry. Not clear enough directions, my bad. Read it in your head. Second step's always the same. What are we counting? Here, wait. What are we counting? Callie, what are we counting?
How many golf balls Rob has?
How many golf balls Rob has? Rob has blank. Our unit, golf balls. You can put in all if you want, or you can end your sentence there. Our
I had a weapon.
second step doesn't change. Counting golf balls. All right, kiddo, so you're ready. Good job. Our third step doesn't change either. We're going to read that problem and model it. How to read the first sentence. 3 packs of golf balls. What is that going to look like? Really good that habit. Never go and put that. What is that going to look like? All right, what is that going to look like? What does that mean, though? What am I drawing?
You can draw a circle if you want. You can draw a star model if you want.
Sure. Beautiful. I could draw 3 circles. That could be my 3 packs of golf balls. I'm going to draw mine as a bar.
Yeah.
But choice is yours. Pick your poison. And I'm even going to label them. What am I going to label them? What do you think I should put on there? Avery?
Excuse you, Mom. G1, G, G1, G2, and G3.
What does G stand for? Are they each golf balls?
A pack.
Oh.
So, G1.
There we go. So Avery first was like, maybe golf balls, but these are not golf balls that we're drawing. These are packs. So we're going to name them P1 for pack 1, P2 for pack 2, P3 for pack 3. We've got our 3 packs. Connor, what's that? Sure. What?
We've seen these problems before.
We've got our first sentence drawn. Let's go to our second sentence. Penelope, can you read that second sentence from there?
Each pack has 6.
Each pack has 6 golf balls. Ava, what does that mean we're going to do?
Means we're gonna set golf balls in each, but each has 6 in them. But there's 4 left out, so we gotta leave out 4.
Nope, that's not what we're going to do. Penelope, can you read that sentence one more time? Why don't we listen to the sentence, Eva?
Has 6 golf balls.
Each pack has 6 golf balls. What am I going to do with that information?
So we're gonna set 6.
I'm going to put 6 in each. These are my golf balls. I've got 6 of them in this pack. 6 of them in that pack. 6 of them in that pack. I didn't say that. So far, we've got 6 golf balls and our 3 packs. So far, so good. All right, Ava, read that next sentence.
There's 4 golf balls left.
Nope, that's not what it says. Read the sentence of the problem, please.
Rob also has 4 more golf balls.
Rob also has 4 more golf balls. How am I gonna model that? Jordan, what are you thinking?
We can make another box
Okay,
that went with 4 in that box.
where are we gonna put that box?
Maybe either under or beside.
Is it gonna be under or beside? Because those are 2 different things. Which one do you think we should do?
I think we should do beside.
Why do you think that?
Because if we put it under, it wouldn't make sense because that isn't like
Let me ask you this question, Jordan. Who owns these golf balls? Who owns these golf balls? Who owns these ones? Who owns those extra 4? They all still go to Rob. Which, don't do that. Which means I'm going to add them on to Rob's section. So Jordan, you're exactly right. We're going to add a little section. But it's not a full pack, is it? Nope. It's like a piece of a pack. He's only got 4 extra. This is where it gets tricky. Because now, Ava, we need to make an equation. We've got a lot happening. Who thinks they can make an equation for everything?
I know what you mean.
All right, Bowen, let's see if we can figure it out.
So you have to add the 3 6s together.
Okay, so what would my equation be?
6 plus 6 plus 6.
That'll work.
And equals
Nope, I want to do all of it in one step.
plus 4.
Beautiful. So in order to add up how many golf balls he had, we did 6 plus 6 plus 6 plus 4. We could also do 3 groups of 6. 3 groups of 6 plus 4 more. Do we know where this came from?
Yeah.
Do we see 3 groups of 6 plus 4 more?
Yes. 3 6s. No.
On your test on Friday, you will have to make an equation that has both steps in one.
Wait, test?
If I were to solve this, what might I do? If I were to solve this, what might I do? Marley?
First, you find out what 6 plus 6 is.
Sure.
And you add
I'm going to first figure out either
6
6 plus 6 plus 6, or I could just do 3 times 6 because they're the same value. Give me a secret then if you already know that value. Please don't yell it out loud because people are still thinking. But if you already know the value of 3 times 6, give me a secret then. Be patient while people are still thinking.
What's that?
We've already had this conversation. Maverick, what'd you get?
I got 18.
18. Riley, was my answer 18?
Yeah. No.
No?
Oh. 16 plus 4.
How much Jordan plus 4?
Need 18
We still need to add that 4. All we did was just add or figure out this chunk. We now need to add 4. Raise your hand if you know that sum.
Oh, it's 22.
Raise your hand if you know that sum. Mason, what you got?
And so what I did is I added 3 6s.
22. 18 plus 4 is worth 22.
Yeah, same.
I got a lot of numbers happening on this page. How do I know which one is the number of golf balls he has? I got a lot of numbers. I got 6s, I got 4s, I got 18, I got 3, I got 22. I got a lot of numbers. How do I know which one is the number of golf balls he has? Avery, what do you think?
Maybe you could check the, if you're, you could check, oh, I know.
You know, that's why you're raising your hand. That's the signal that's hoping you know.
You could check all, you could add them up, and then you could look for the right number that, the number that you got on the page.
Sure. We know that it's going to be 3 groups of 6 plus another 4. Doesn't make sense that he has 6 golf balls, does it?
No.
Does it make sense that he only has 4 golf balls? No. He's got 22